Welcome to Energy System Modeling Course Exercise 2. Again, you can find the exercises from the Moodle folder. So from here, you can see that there's the Exercise 2 PDF. So in the first assignment, we're going to train, or rather the only assignment in here, we are going to train the neural network to take into account some previous historical data on these sites and test it against this year 2024. And actually in here is only 2023, but for the sake of the exercise, we might include another year in here as well. So a neural network has to have inputs and it has to have outputs in the training data. So what we'll be doing is we'll be gathering that input data from these sites, and the output data is going to be electricity price. So what we'll be trying to do is to predict electricity price based on various input values, such as temperature, wind speed in Finland, and also these electricity power plant production amounts. So in the beginning, we are starting from this transparency ENTSO-E. So when you go to the site, you'll have to register to it. So I'll just log in. And what you can find from there is this generation tab. And I already have these recently used data views, but you can find it from here. So actual generation per production type. So let's see if we can access that. So now it gives us this data view. And what we want to have is we want to have data at least from years 2023 and 2024. But as I said, we might take another year. Actually, 2022 was a really good training year for the neural network since there were so many unforeseen events that put the electricity market into some kind of a turmoil. So let's take this one at first and just select the random date from there and done. And then I'm gonna set the time to universal time coordinated. And then I'm gonna switch the country to Finland. And now it should have updated the values. So now we're in 2022 and you can only export yearly data from here. So export data, and then there's the actual generation per production type. And since there's a lot of data, it might take a while. So let's go ahead and open the CSV file. And as you can see, everything is again in one of these cells. So we have to divide it into columns. So what I can do is click on the first cell and press Shift Control and downwards. It can select all the cells from here. And then Data tab, Text to Columns. Let's try that again. Yeah. So delimited, next, and we're going to delimit it with comma. So now you can see there's a whole lot of values in here. So this is 2022. And I want to go ahead and delete these empty ones. We're not going to be putting these into the feed for the neural network. So let's take out these ones. So delete the columns and let's see how many columns we have in here. There's 12 columns. So this is going to go into the neural network feed. And what we have to do in here, if we want to have an hourly resolution, actually that wouldn't matter too much if the resolution in here changes, if these were the only values. Actually, there is one. Let's go backwards still. Did I delete one wrong one? This one has to go as well. So delete these ones. So now there's 11 of these. So again, what I want to see is if the resolution in here is correct till the end, because it changes along the way, as you noticed in the previous exercises. But during this 2022, it doesn't change yet. So we are going to take these ones, and I already have in my exercises folder this training data set. So we'll see if this one matches what I have in here. So we have actually there's 12 of these production values in here, so we are going to see what's missing from there. So there seems to be one missing from here, solar actual. So let's see if that one was in the original. Yeah, there's the solar actual, and it starts to be 0 from here on out. So we're going to save the solar one still from here, since it's in the next years to come. So let's take these ones out and retain the solar one. So delete these ones. And I might go ahead and just, rather than having this n/e, I'm going to put 0 all the way through. So there isn't any solar production according to this in 2022. So let's go to the training data set and we'll paste this one in here. So there's the wind onshore actual aggregated, and let's see if it matches the one in here. I just had these beforehand in here to see in which column I would put these. The order doesn't matter. If you have the same order in the so-called training data and the validation data, you can put whatever kind of data tags and whatever kind of order in here, as long as they are in the same order. So now I'll have to go and see the year 2023. So the same things, we can close this one. So the same thing we have to do with 2023. We have to make sure that it's universal time coordinated, it's Finland, and from here it's generation per production type. So I'll go ahead and click this 2023, and let's put some random date for it to acknowledge that we are changing the year. Seems that it did. And again, let's get the CSV, actual generation per production type, and this is year. So again, it's gonna take some time. Didn't seem to start to export it. I'm just gonna make sure that this is updated and then try it again. Now it seems to be doing it. So this is 2023. We can go ahead and open this one. Again, shift control downwards, data, text to columns, and not fixed with, but rather delimited with comma. And again, we're going to have to delete the ones that we don't need, as we did before. And most likely now there is going to be some solar in here, solar actual, as you can see. So that's why we needed to save that in the previous one, since we have 12 initial values in here. And now comes the hard part, since 2023 was the year in which in the previous exercises, we noticed that in 3,361, if I don't recall wrong, yeah, this one starts to change. So this is 0, 0 hour. So if we're going to take an average out of the next hour till 1, what we have to do is take, so we want to have an hourly resolution. So average out of 1, 2, 3, 4. So that's gonna be the next hour values. And the next one goes into here. And again, we have to drag it to the right. So it takes into account all of these ones. So 1, 2, 3, 4, and again 1, 2, 3, 4. And now there's 2, 4, 6, 8. This is going to be tricky. So let's go again. 4, 8, 12, I think. So this one is, yeah, the final one. And now if I paint these ones and just double click it, I'm going to get all the values averaged from the 15-minute intervals into hour. So let's press Control C rather, and paste the values into here. And now we have the option in the Home tab of going into this Find and Select, go to Special, and find blanks. It's going to again take a while since there's a whole lot of data, but let's be patient and then delete the sheet rows. You could use, for example, the Excel offset function to accomplish the same thing. But now what we have averaged the values, so we have hourly resolution in here. So we can copy and paste them in there. And let's take these ones, copy paste these, and let's see from where on out. I'm going to have to go upwards from here and copy and paste them here. So let's see how many values I do have. I do have actually 8,760 values now in here. So these ones are 2023 values with an hourly resolution. So what we can do is we can go down here and we can just paste the values. So it continues the same values from there on out. Okay, so now we have the years 2022 and 2023. And we might go ahead and do the 2024 now, since we're at this site. So let's take 2024 and some random date. It doesn't matter since you're exporting the entire year. Just make sure that the data changes. And again, actual generation per production type. And this time is going to be again different since from the beginning of the year, you already have the 15-minute resolution. So we're going to have to do that averaging for the entire year. And as I said, the averaging could be done, for example, with this offset function, or you can go ahead and use Python in the beginning already. So now it's downloading it and we can open this one. And again, shift control downwards, data, text to columns, delimited, and finish. Delete the columns that don't contain the information that we need. So these ones, and let's check that there is 12, there's 13, yeah, there's geothermal. We don't have that in Finland. Yeah, no, 12 of these. And since we have these starting from this 15-minute, what we can do is have the average. So average out of these ones like so. And let's go ahead and put somewhere close to 12. Yeah, okay, 13. So from here, 1, 2, 3, 4, and this one, I presume. 1, 2, 3, yeah, and the fourth one up there. So like this, let's do the same thing to the next one. Otherwise, it's going to destroy the original data. So it was in home, find, select, go to special, blanks. Now it's going to take even more time since we have the entire year as the with the 15-minute resolution. So let's be patient again, and after it's selected all the blanks, we're going to delete them. And this is a really brute force kind of way of doing this. You can find more elegant ways into here, but this is rather fast. We don't have to code anything. Might take a lot of time, but usually when Excel says that, it's a matter of seconds. Yeah. So now we have our validation data. So I'm going to open this validation Excel file and put all of them into here. Yeah. So now what we still need, we need the natural gas price, wind and temperature data, and then we need the electricity price. So let's move on ahead in the list. What we have now is next is the Ember site. So if you click this one is actually rather nice since from this Ensoe, you could also find the day ahead prices, but it's again only 1 year you can take it from extract it here from here. So from this Ember, what you need to do is just press this one, European wholesale electricity prices hourly. So that's what we need, hourly resolution. This Ensoe provides the 15-minute resolution, but this Ember site, at least at the moment, we can find hourly resolution from here. So let's take Finland. And the nice thing about that is you only have to press or click with your mouse once and you get everything from Europe and it's fast. So let's do the data text to columns. And again, it seems to be, yeah, no, it seems to show some troubles with the Excel. So now what I have in here is there's the time tags, and then there's the electricity price, hourly resolution, and universal time coordinated. So we might automate this one as well, but I'm just going to scroll till 2023, rather 2022 appears. So it starts from here, and from here on out, I'm going to take all of these prices. I'm going to take Control C, and let's put them into this training data. So there's the electricity price, and I can go ahead from here, and that's where the 2024 starts. So let's Control X these ones into the next validation. And now if I go down from here, this is where 2025 should start. Yeah, there's only 428 of these values since we are not too far in the year yet. Okay, so now we have the electricity prices in there. Hopefully I got that right. And of course, you can only extract 1 year at a time, but I decided to make it a bit faster. So the actual generation files, we can delete or close them rather. We already have that data. And then we have the Finland electricity price data. So the Ember one is rather simple. So after that, we are going to go to Ilmatieteen laitos, so Finnish Meteorological Institute, and you can write that Finnish Meteorological Institute and data downloads into Google. Since this link, what I gave you, actually is in Finnish, and if you click from here, that this is the havaintojen lataus, so data downloads. So if I press it in English, it's going to toss you up in the front page. So let's say Finnish Meteorological Institute and data download. Data observations is the site name. So we're going to have wind speed and air temperature. Let's take those ones. And hourly resolution. And let's take the mean value, universal time coordinated. And we can choose the time period from here, which is really nice. So let's take the year 2022 and January 1st, 2022. And we might actually go to 2025 and from there backwards to December 31st. Yeah. So what this site offers you is a lot of these observations, and you can select the resolution, which is really nice. So you have 10 minutes. Of course, it's not the same as 15 minutes as in the electricity price or production nowadays. So you might have to write some code to match that. But now, since we're operating at an hourly resolution, this is nice for us. Universal time coordinated, and now I can get this map from which I can see the observation stations. I can write the name of the observation station there. Let's see if I can toggle this map. Yeah, shift control and scroll with the mouse so you can zoom in there. And then by releasing that shift control, you can just drag this map. And what we're doing, we're trying to train a neural network with certain input variables to predict the electricity price in Finland. And since this temperature and especially the wind speed is related to, of course, the wind production or the wind power production rather, what we want to do is we want to take a representative point. So it's going to be in the coastline somewhere here, since most of the wind power production is located on the western coastline in Finland. Of course, if you were to do this more accurately, you're going to take multiple points from here. But since we are just trying to demonstrate this, we're going to select, for example, this one. And there are data download or the download observations rather button in here. We can press that and it's going to take a while again. But what we have is the air temperature and the wind speed. So the air temperature would be better to take some kind of an average out of the entire country. And for example, for solar energy production, what you could download from here is you can see that there is the, let's see, radiation observations. So you could take some kind of radiation amount. So if there is wind coverage, that's going to take care of that. If there's a correlation between the electricity price and that solar radiation amount, then you have the data from here. But now again, it's going to take some while since we have a lot of data points. And remember that in 2024, it's this karkausvuosi, so it means that there is one extra date or one extra day rather in January, no, in February 29th. So that's why that year has 24 extra hours, so 8,784. So again, we have to be patient. So now we got it. And let's take it, for example, with this Excel format from here. And it's going to open it for us. We have wind speed and air temperature in here. So let's see, there's wind speed and air temperature. So what we can do again from here till the end, we can see if it matches. So I'm going to just paste it in here. Yeah. And from here on out, it should have, let's see. So this should be hourly resolution 2024. Oh yeah, no, no, I think got it. So from here on out till the end, there's still 2 years in here. Oh, sorry, I put it to the wrong file at first. So that's why I was wondering where there was so much data in there. So let's take these ones. Still Control X and let's go to the training. So training and till here. And from here on out, I'm going to take it Control X to this validation. And let's hope the length matches. Yeah, it seems to match. And now you can see again some irregularities or missing data in here. So in the wind speed, we don't seem to have all the values. And let's see if we can find that. I'm pressing Control in here downwards, and it doesn't seem to find these values. So what I can do is, for example, if I want to see how much of these ones exist in there, what I can do is take the, actually, I might not want to take the Control F and replace this one, because if I were to do that for the temperature as well, it would replace these negative ones. So let's find if we can see the if is number. So is number, this cell, that's true. If I drag it down, there's false. That's good. So we can use that if is number. So if is number, if this cell is number, what you're going to do is you're going to return the same number. If it's not a number, then you're going to have average out of these ones. Actually, this is a really small amount of average numbers, but I can drag it till here, and in here I can start extending these. So let's take an average out of these ones. And if I just double click it downwards, now you can see that here where you don't have these numbers, for example here, it's going to give us the average one. So again, we have parsed together 8,786, as you can see in here, elements for the wind. And actually, I might do the same for the temperature. I don't know if there was some missing data from there, but let's make sure. Yeah, and now I can copy this one to the other folder, or the other file rather, for the training data. And let's see the same in here. So I'm going to copy and paste it in here. And remember that I'm going to have to switch this one a couple of cells upwards and downwards. This is the one that we did in exercise number 1. So, and actually now that I think about it, I might have missed in the other file. Yeah, so in here, I'm going to have to drag this one upwards a couple of notches, or cells rather, like this. So now these should be averaged in the same way. If something is missing, then we can go ahead and delete these ones. and the other one, the same thing. Now we have the averaging done in the same way. And let's go ahead and put these ones in here. So that makes sure, that ensures for us that there is no data missing. So one thing more I wanted to add in there was the natural gas price. And that was a tricky one to find in Excel or in like vector format. So you would have numbers. What I found was this tradingeconomics.com. So why would natural gas price be affecting Finnish electricity prices is that usually when there is the highest marginal cost, it comes from gas turbines. Actually, now that I think about it, in 2022, the natural gas price was in such a high level that gas turbines, when they operated, they started using light fuel oil rather than natural gas. So that's something that you could also include in your neural network input. But let's go ahead and see if we can extract the data from here. So we want from 2022 till 2024 end. So if you try to export it, it gives you that, are you a member? You want to log in? Sure, we want to log in. And in some cases, you might be able to sign with Google, but if there is a site, I want to show you a technique. If there is a site from which you can only extract graphical data, now we're going to deal with that. So we can download the PNG image out of here with the certain resolution. So we have this PNG image that, let's see what it looks like. It looks like this. So let's go ahead and use this one. So what you can extract the data from that with is, for example, a site called Automeris. That's something I found with Google, and that's a freeware site. So you can launch the version 5 if you want to pay for it. I guess that was, at least at this time, there was some paid version, but Access Archive version 4. Yeah, so version 4 from here. And we're going to load the image. And this was this one. So align the axes. And let's go ahead and proceed and press from here. It's 2021. In here, it's 2025. So what you want to do is you want to create as much resolution in here as possible. So Y1 goes into here, and Y2 goes into here. And as you can see, this isn't exactly in the same unit as you saw in the site. So it's in the site, let's see, in here. Uh, yeah, it's in US dollars per million. So this is British thermal unit. So it's in a rather funky unit. So we might want to change that, but actually with neural network, it doesn't matter. If the same year is in the same unit, then it doesn't matter. So I press the axes into here, and I'm going to say that the first dot in there for X is 2021. The second is 2025, where it starts. The next one is 1, as you can see from here, Y, and the second one seems to be 10. Okay, so let's go ahead and run. And I can use these 10 delta X, delta Y. So you can see there's some smaller amount of data points if I make it more accurate. So you can see you can extract a lot of data from here. But actually, I might try to try it with these ones. So we want to press this view data, and you can even download the CSV from here. But I'm just going to go ahead and press Control A, Control Z, Control C rather, and then I'm going to put it into this, let's see, data. So what I have in the data folder in here, uh, let's put it in here at first. Yeah, so there's the resolution or the time in here. So actually we might put it in here. So I wanted to put this time and price tags in here because I have a code in Python that does, let's see if I'm going to put it into, draw it in the whiteboard. So let's go ahead and open this one. So what we have in the data is when we have 2022, for example, it starts from here and ends in here. We only have a couple of points in there like this. And we would like to get an hourly resolution. So there's the price and there's time. And we have a certain amount of points in there. So what I want to do, and I wrote, or rather ChatGPT wrote a code for this when I prompted it, that I want to interpolate data with a uh, certain amount of points that I want to extract from the original data. So what it's going to make, it's going to make a smoothing fit for it. You can control the smooth, how well it fits to all of these points. So I'm going to provide you the code example, and that's something you can try by yourself. That is a rather easy task for ChatGPT if you're familiar with prompting. So you're just going to say that make a smoothing fit out of the original data. And then what you're going to do is you are going to give the resolution in a way that there's 8,760 points. So you're going to read these points not from the original points, but rather from this uh, fit, the smoothing fit that ChatGPT based code makes in Python. So for that, what I did in there is, first of all, I selected the, let's select the year 2022. It starts from there. So let's go ahead and delete these values. And Control X, and I'm going to move them here. So it starts from 2022. And these ones from 2023, I'm going to put a row between there. So this I would have to scale from 0 to 1. I think that's the easiest one for the code. So let's see. What we could actually do is we could make it in a way that just this number minus 2022, and copy and paste this one here. And now if we are going to see what kind of a swarm of points we have, it starts from 0, goes to 1, and you have these points in here. So we want to make a smoothing fit. So the same thing goes for here, 2023 and 2024. And actually, since I have 2 years in here, something really, oh yeah, it continues after 2000. I have the previous numbers in here. I'm just gonna have to delete those. So from here on out, I'm gonna delete these ones. And if we would like this data to go from 2023 beginning till 2024 end, so let's go ahead and delete those ones. There's actually 2 years in here. So since 2024 is going to be having this extra day, this might actually make a tiny mistake in here. But what I'm going to do is I'm going to have this cell we're going to minus 2023 like that. Actually, then this is going to be 0. So let's take this one out. So 2023 till there, but now it's going to go not up to 1, but rather up to 2. So let's go ahead and divide this one with 2. So now what I've done is I've scaled the values starting from 0 in the training data and going up to 1. So there's 2 years worth of data. And we want to generate another similar file. So let's go ahead and save this. So I'm going to save this one to, let's put, for example, data validation. And by the way, now I did it the wrong way around. I was supposed to have 2. Let's go and take cancel just a bit. So now I was a bit too fast with this. So let's get some something back. So it was supposed to be till, so let's delete that one. And it's going to be till 2023 end. Yeah, sorry. So let's do that again. 2023. And it's going to start from here. So there was actually, yeah, no, it's correct. And from here on out, you didn't have this data. So I'm going to delete that one. So now this one is only that one minus 2024. So this is for the validation data. And for the training data, we have these 2 years rather than 1. So that one divided with 2, and now it's scaled for the training data. So this one goes into here, paste the values. And in here, let's see, from 0 to little over 1. So let's take these ones out, and now it's correct. Yeah, sorry for the hassle. So these ones, I'm just going to make a new Excel file into here. So that's going to be data validation. Didn't seem to work, so let's do it again. Data validation, like that. And it's going to go into here, and there was time, and there was price, like that. And then we're going to go ahead and delete those ones from here. Yeah, so there's time and price, like that. Okay, so for the Python code that I have, it's this smooth, and let's put in here, actually I might want to change this one still to data training, like that. So let's go ahead and put it here, data training. So there's 2 years. I want this one, so 8,760 elements, but I also want the other, the second year. So this is going to be times 2. 17 by 20. So 17 by 20 is going to be the amount of data points that I wanted to generate. So let's try what it looks like. It's going to take just a little bit of time, and remember, okay, so there seems to be some error in here. So what we can do is give the code. Let's go ahead and open up a new window of ChatGPT and give code is this, error is this one. So let's see if we can fix it. Ensure the time vector is sorted. Okay, let's see if we fix the code with this one. So I'm going to copy it and I'm going to give you the updated code. So let's go ahead into here and try it again. And now it seems to work. So there's the smoother than interpolated data. It seems to, in some cases, make a little jump, but for our case, this seems to be sufficient. So let's see from this folder that we have this new data smoothed in here. So if we can find the right amount of these prices. So there's 17,520 data points. So if I were to put it into this training one, it should fit in like a glove. Yeah, that's where it is. So again, this is a rather funky unit for this natural gas price, but it doesn't matter since it's since it's the same in both cases. We're going to have the natural gas price in the same unit in here as in the validation data. So now what I need to have is to run the code with the validation. So in here, validation, and in here we have 8,784 hours rather. And let's close down the new data smoothed, which is the file that it writes it in. So I'm gonna actually go ahead and delete that one from here. So let's try and run it. And now if you try and run it with a different smoothing parameter, so this can vary from 0 to not to 1, but maybe up to 100. You can try that. So it's going to be smoother if you increase it. But in this case, the data smoothing looked rather nice. So I'm just going to go ahead with this number 2 parameter in here. But actually in here you can see it's a bit too crude. So let's try and decrease it and see what happens. It's a little better. So let's go ahead and decrease it still. And now for our case, I think it could be okay. Maybe a bit more, 0.02. So let's try that one still. And there's a little overshoot in here, but we'll go with this one for the sake of example. So now what we did is we extracted graphical data from this site. We used this online tool to obtain the data points. So this is really nice. We don't have to do any manual clicking in here. And then we interpolated based on this kind of a smoothing function, new data points in between the points in a way that we have a certain resolution. Because in our validation and training data, this switches between an hourly resolution. So let's go ahead and see the new data smoothed, and we have 8,784 elements. So now we can go into validation. We have the natural gas price in there. Okay, so now what we're going to try and do is we're going to try and train the neural network with this training data. What it takes in as inputs are all of these values from here. So these values. And then the output is going to be this one. And in the lectures, we had a brief introduction to this neural network. So I'm not going to cover that too deeply in here. And we're going to let ChatGPT or some other AI platform to cover that for us. So what I did in ChatGPT, I gave a prompt such as this. So I have data. You want to be precise in here. I have data in Excel, training, and validation files. Both contain 16 columns. So I checked that, yeah, there's count 16 columns. The first 15 are inputs for neural network, and the final column is the output. I want a code in Python that reads the files, generates a feed-forward neural network with one hidden layer and 100 nodes. So this is something that you want to know what this means, or you can ask ChatGPT to make a recommendation. What kind of a neural network and what parameters should I put it in? For example, I didn't define the activation function in here, but it gives it me as default. So I want a code that reads the files, generates feed-forward neural network with one hidden layer and 100 nodes, trains the network with training data, and tests it with validation data. I want a figure after the training that shows the results column versus the neural network results in both, should be both training and validation cases. And I didn't quite get I got one error, so I wasn't, let's see, there was some values missing. Hopefully I corrected those ones already in the Excel files. So it gave a correction to it. And I said it to it that give me the entire code. And then I wanted to edit the figures in a way that it shows the results as a function of time. Each line in the Excel represents files represents 1 hour. So that was the prompt that I gave to ChatGPT. So I gave one prompt. I gave one error report from this Python, and that was due to non-existent values in the Excel files, and then I wanted to fix the figures. And on top of that, what I had to do in Excel, or rather in the Python, remember if you have these packages, you can from the settings, main menu settings, and Python interpreter, you can install those packages from there. So I can write pandas, and you can see install package. I already have it, so I don't have to install it now. And it wanted to use this TensorFlow, so that took a while to install. But let's see what it gives us, and hopefully I have the training and validation data correct in here. So new data smoothed. I don't need to save that. And let's try and run this neural network. It's going to give some not errors per se, but some notifications out of here, out of this code. But it should start training the neural networks in here. You can see the epochs. So it's going to take 50 rounds to train it. And then we should see the neural network prediction for the year 2024 based on 2022 and 2023 training data. So this is going to take a while, but it shows that it's actually working pretty nicely. And before I did only the prediction based on 23. So now I would assume that the prediction for 2024 would be a bit better than before, but we'll see. And now it should give us the figure. And as you can see in here, you see the training data. It caught up to the spikes rather well. But for example, in here, I think it was the Norwegian company that made the 10 times larger bidding to the electricity market in terms of their power that they were supposed to make. So that's why That's why there's this minus 500. It didn't quite catch up to that. And as you can see in the beginning of 2024, there's a huge spike in here. It didn't catch up to that. So nothing in the data indicated that something like that should have happened. In here, I think it's a rather good fit. It's a rather good fit. So the neural network predicted based on the values that I gave it, the electricity price, and it's a rather good fit in the beginning of the year. But in here, it starts to predict negative values. And that's something that might be most likely due to the training data. Of course, it might be due to the neural network structure and the training procedure as is, but still, I have doubts on that it would be due to the actual the training data. So what you would have to do to improve this uh, prediction is to gather more training data. You would have to gather more weather data uh, related to, for example, this solar radiation amount. You would have to have data on, for example, the Norwegian water reservoir amounts, uh, even something like corona pandemic, to which percentages of people it affected at a certain point. For example, how many peoples were quarantined at a time, but in quarantine rather at a time. But where to get that data? That's the real hard part with neural networks. So, but you can also feed it kind of irrelevant data. It's going to find out if there's a correlation between that irrelevant or the data that you think it's irrelevant and the output variable. And there can be multiple output variables. In this case is, oh, in this case, rather, we only had one. But this is the procedure in the exercises that I wanted you to go through. So you can extract data from various sites. You can parse it together for hourly resolution, and you can even extract numeric data from graphical figures. And then you have the ability to generate this neural networks. And as you can see, there's only very little prompting that you have to do. You just have to be precise with it. And that's something that you have to train with these AI tools. So that was exercise number 2, and all of these files will be provided you in the Moodle folder.